All right. Well, thank you everyone for, coming here in the middle of a burn to talk about AI and astronomy. So I am not a space nerd in the conventional sense, but I am an AI nerd, and I've been fascinated specifically by artificial intelligence for a few years now. And over the past 3 or 4 years, I've given several talks on artificial intelligence and what it is and how it might impact us as the human race, right? So the approach that I take to AI is very techno-philosophical. I'm fascinated by the programming part of it. I'm fascinated by the algorithmic part. What really draws me is the philosophical aspect, right? So when we're developing artificial intelligence, which is the literal replication of our own intelligence, what's absolutely fascinating is that it brings to light what that means for us. It means that it brings into question what kinds of jobs we'll do in the future, what kind of lives we could live in the future. And a question that often comes up for me is, what is our purpose in this universe? And I'm sure within this context, this question can come up in so many shapes, so many ways, shapes, and forms for each and every one of you. And there's no real right answer. There's no absolute truth. Sorry? Recycling, right. There you go. That's one purpose. I'd say there's no absolute truth, but if I were to venture a guess, then I would say that our purpose is to explore. Our purpose is to discover. And Carl Sagan said it best. He said, "Exploration is in our nature. We began as wanderers, and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean, and we are ready at last to set sail for the stars." My belief today, and the reason that I want to talk to you about AI and astronomy, is that I believe that it is only with the help of artificial intelligence whereby we will augment our own intelligence and set sail for the stars. Now, let's talk a little bit about the awe of artificial intelligence, right? Ray Kurzweil, a futurist and former director of engineering at Google, famously said, "Our technology, our machines, are part of our humanity. We created them to extend ourselves, and that is what is unique about human beings." So for all of the people who are afraid about what technology might mean for us, the hope is that in the future we will build artificial intelligence where we can merge with AI and augment our own intelligence to create a better society. But of course, this only happens with the right ethics, policies, and mindsets in place. So let's start with some basics, right? How intelligent is artificial intelligence? First, I like to kind of define what intelligence is. And there are very many ways of describing it. And I think we've come a really long way as a species to identify the different kinds of intelligence that exist within us. But simply put, intelligence is the ability to solve complex problems. And if we think about the types of AI that surround us today, we can kind of think of it in three blocks, right? There's narrow AI, general AI, and super AI. Now, most of this AI that we're surrounded by today falls under the realm of narrow artificial intelligence. I don't like the term, and it's often interchangeably used with weak AI, and I don't like it because it takes away from the awe of artificial intelligence. Now, narrow AI systems refer to those systems that have a predetermined task, that are given a predetermined range, a data set, so to say, and that are asked to perform a result based on that data range. And most of the AI that we're surrounded by today is narrow AI. So that goes from autonomous vehicles, which are very complex but are actually made up of multiple narrow AI systems, to Siri and our AI assistants that we rely on a day-to-day basis. General AI is a hypothetical point in the future where we foresee that narrow AI will evolve to match human-level general intelligence at every step. So today, narrow AI is really good at doing cognitive tasks that are specifically related to linear thinking. So output A to output B, logical linear thinking. But the idea is that general AI will be able to surpass and match our breadth of knowledge and our breadth of intelligence, which is the ability to do multiple things at the same time, to learn different tasks at the same time, including learning a language or playing a game of chess, all simultaneously. Today, we're not surrounded by any sort of general AI, but because artificial intelligence is on an exponential curve of development, when we jump from narrow to general AI is unprecedented. It could happen anytime. And then the jump from general AI to super AI, where we'll have AI that far surpasses human intelligence, will be even faster. So, like I said, AI surpasses humanity mostly in linear thinking. And so when we think about astronomy and we think about the mounds of data that astronomers have to deal with, what we're really using AI for today is linear thinking, is pattern recognition, image recognition, and data analytics. So I'll dive a little bit into how machines learn and how machines think before we kind of dive into AI and astronomy. AI is a general subset of a technology that's developed to accomplish certain tasks. But within AI are different subsets, and really the most fascinating of these are machine learning and deep learning. And these are the sort of algorithms that are designed to learn how to think for themselves. So we go and feed massive amounts of data to these programs, and they learn how to classify images, or they develop some sort of output based on that data without the human programmer having an input into what that result might look like. So an example of supervised learning within deep learning systems, which is how machines learn, is that we can feed a system images of the moon and the earth until it can identify both. But what's really amazing are unsupervised systems, where we have deep learning algorithms that essentially mimic the human brain and human neural networks to learn tasks. And in unsupervised learning, there's no target to predict. The task is to just learn the structure without being told what the structure is. So that's really fascinating, right? You imagine you're giving this machine mounds and mounds and mounds of data, and it's essentially figuring out for itself and making its own decisions about what information from that data set is relevant. So now let's go a little bit into AI and astronomy. And one of the key ways in which we're currently using artificial intelligence within the astronomy space is to identify exoplanets. Exoplanets are those planets that exist outside of our solar system. And we have thousands, almost 60 petabytes of data, of images of the night sky through observatories and telescopes like the soon-to-be Vera Rubin Observatory in Chile and the James Webb Telescope. And if you think about just the amount of data there is no way that even if we had tens and hundreds and thousands of human astronomers trying to classify those images, there's no way we'd be able to parse all of it and essentially go through all of it and classify all of it. But today we can use artificial intelligence to look at these images and observe changes in light curves so that they can see and identify whether or not there are exoplanets in other solar systems. And they do this essentially by identifying spikes and dims in the light curves of these exoplanets, which is then reflected in their host stars. Another really fascinating sort of use case for me in AI is that of creating galactic forgeries. Now, for a long time in science and space, we kind of left aside the role that creativity and imagination have to play. But today we're using artificial intelligence to create fake images, but very detailed fake images of the night sky, of galaxies, and then using these fake detailed images to run simulations and test predictions about the universe. OpenAI's DALL-E has been really famously, a number of you may have even used DALL-E, has been really famously sort of used in this space of creating generative models based on text prompts. So essentially, if you wanted to explore how AI works, you can use DALL-E, open the application, enter a really, really random prompt like, I want to see what Garfield would look like if Garfield starred in Seinfeld. And DALL-E will create some mind-blowing images of things that have never existed before, right? And the amazing thing about this is that DALL-E is not just pulling images from existing data sets like Google Images or Yahoo Images, but is actually creating essentially engaging in artistry by developing images that have never yet existed. So when it comes to astronomy, we're now using that same sort of evolved model of DAL-E to create fake images of the galaxy and study them. AI is also really good at observing the night sky, right? Again, this comes to data parsing. We're using artificial intelligence, specifically today an algorithm known as SHEEP, which is readily available on GitHub for those who are interested in exploring it, which is essentially a machine learning pipeline for astronomy classification. So SHEEP can go in, take all of these mounds of information and data, existing images that have been taken by existing telescopes, and classify whether something that the AI is observing is a quasar, a supernova, a star, an exoplanet, and so on. And finally, I really love this one. We're now extending that to get AI to search for serendipity, right? So historically, a lot of the discoveries that we've made about the universe have been by chance, right? William Herschel discovered Uranus by chance. And the hope is that AI will be able to do that as well. Because of the advent of deep learning and unsupervised learning models, we now have AI that can go and essentially do anomaly classification. So if there are images of things that we've never identified before within the realm of astronomy, AI will be able to point out that we haven't identified those images and point out those anomalies, which essentially points us to serendipity. And finally, of course, there's AI-powered space travel. If we want to be explorers, if we want to explore the vast, vast universe, we absolutely need artificial intelligence to help us do that. So today we're developing satellites that can work autonomously in very much the same way that we have self-driving cars that can make decisions, that can sort of self-heal in case of an emergency, and that don't require a human actor involved to sort of drive those satellites and drive that deep space travel. So, you know, as AI evolves, I really do think that the possibilities are endless. When we make that jump from narrow AI to general AI, it's very possible that we will have systems that will give us a better understanding of how we can utilize them to then further understand the universe. I always like to talk about the technological singularity, which is something that drew me into AI in the first place. And the singularity is posited as a hypothetical point in the future where we will merge with our machines, where we will develop artificial intelligence that is so intelligent that we'll be able to saturate the entire universe with our intelligence. This is the destiny of the universe, as Ray Kurzweil said. Ultimately, the entire universe will become saturated with our intelligence. Thank you.